Have you ever played with a slinky? A slinky is a type of spring. When you hang the slinky, it will spring back and forth until it settles at equilibrium. The motion of the slinky is based on an idea called the spring constant. All springs have a characteristic called a spring constant, which describes the strength of a spring. If a spring is very stiff, it has a high spring constant, while a spring with a low spring constant, like a worn-out slinky, is very loose. Robert Hooke was a scientist that came up with the spring constant formula that describes how much force a given spring exerts if it's stretched over a particular distance. F equals negative kx. Here, F is the applied force measured in newtons, N. K is the spring constant measured in newtons per meter, N divided by M. And x is the displacement the spring travels measured in meters, M. The negative sign means that the spring moves in the opposite direction of the force. If you pull a spring down, it moves in the opposite direction when you release it. Identify the question, the information you're given, and the equations you need to use. Let's apply this approach to a spring constant and apply 20 newtons of downward force. If the spring compresses with a displacement of 0.1 meters, what is the spring constant of this spring? Let's apply the strategy we just discussed. What information are you given? A force of negative 20 newtons since you're pulling the spring down and a displacement of 0.1 meters. What equation should you use? F equals negative kx. You know the spring constant equation, but you need to rearrange it to solve for the spring constant. K equals negative F divided by x. Now plug in the values and solve. K equals negative 20 newtons times 0.1 meters. K equals 2 newtons per meter. Sometimes you don't have all of the information you need to complete a problem in one step. To solve multi-step